been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for geometry section 5.4 using medians and altitudes. The median of a triangle is a segment from a vertex to the midpoint of the opposite side. So if I draw a line from A through BC at the midpoint so that those are congruent, that is the median, one of the medians. I could draw another median. What I'm going to do first is I'm going to figure out where I think the midpoint is. So about here and about here. So my median from B is going to go through this midpoint, and my median from C is going to go through the midpoint of AB. Those are the three medians of the triangle. We know they're the median because they come from the vertex and they go through the midpoint of the opposite side. The centroid is the intersection of the medians. So this point is the centroid. The centroid is actually the center of gravity of a triangle, and we may model that in class. The centroid theorem says that the medians of a triangle intersect at a point, the centroid, which we already stated, that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So there are my midpoints, so now I'm going to draw the median. So there is the centroid, and this theorem says that the medians intersect at the centroid, which is that point, that green point, is 2/3 of the distance from each vertex to the midpoint. So what that means is that I'm going to call the centroid point D. So D is the centroid. AD is 2/3 of AE, and this is going to be E right here. So AD is 2/3 of AE, which means DE is 1/3 of AE, right? 2/3 plus 1/3 is the whole. So when you see the centroid, you should notice that the centroid cuts the segment into parts, and there's a longer part than the other. And so the longer part is 2/3 and the shorter part is 1/3. I'm going to just give you the other examples. DB is 2/3 of BG, and CD is 2/3 of CF. The altitude of a triangle is the perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side. The reason that it says to the line that contains the opposite side is when I draw a perpendicular line, it may not intersect the triangle. So it's from the vertex. So here, if I draw a perpendicular line from point A through segment BC, that would be right about here. That would be the perpendicular line. And then I could draw the perpendicular line from B through AC, which would be right about there. And then I could also do it from C through AB, which would be here. And again, those are obviously just estimates. So there are three altitudes on a triangle. So let's look at this triangle DEF. If I wanted to draw the altitude from D through line EF, you'll notice that the perpendicular line would be right about here. I can't draw it over here. If I draw it over here, then it's not perpendicular. If I were to extend out segment EF, in the same way, like this, then if I draw my perpendicular line, again, it doesn't intersect the part of the triangle that is EF, but it intersects the line that is extended from segment EF. DG is the altitude. It's one of the altitudes. Remember, there are three. The intersection of the three altitudes of the triangle is the orthocenter. So I'm going to construct the altitudes by constructing a perpendicular line from the vertex through the segment. And I'm going to do that for all three, from E through DF and from F through DE. This point right here, point H, is called the orthocenter.
I've been waiting way too long.